This Google interview question has an elegantly simple solution. Let's say we have two numbers that can be any value between 0 and 1. The first number is then revealed to you. Can you come up with a way to correctly guess the second number with an accuracy higher than 50%? If so, how often can you guess correctly? Pause the video if you want to, but if you can find the answer in the next 15 seconds, put it in the comments below. And stay tuned so we can explore the math behind it. Let's start by laying out what a strategy with 50% accuracy looks like. Once the first number is revealed, the second number can be either greater than or less than the first one. So to be 50% accurate, we just randomly say it's higher or lower. Now that we know what we have to beat, we can look at a more effective yet simple way to guess the number. To keep things concise, I'm going to call the first number N1 and the second number N2 from here on out. The key to this solution is using the information we get from knowing N1. For example, if N1 turns out to be greater than 0.5, it feels intuitive that N2 is more likely to be less than N1. The same idea applies if N1 is less than 0.5, N2 is more likely to be greater. To prove this though, let's get a visual of the problem. On this graph, the x-axis shows the range of values for N1 and the y-axis shows the range of values for N2. As a result, we have this square with side lengths 1 that contain all possible combinations of values the two numbers can take. Then, we put a vertical line at 0.5 that we can use to gauge where N1 is for our next guess. Now this is where things get interesting. If we graph the line y equals N1, we get this diagonal of the square that makes some very useful divisions. If we look to the left of the green line, we see that all the values greater than N1 when N1 is less than 0.5 is represented by this area. Likewise, looking to the right of the line shows us all the values that are less than N1 when N1 is greater than 0.5. We can then see what percent of the square they occupy, and that gives us our accuracy. These are trapezoids, so we use this formula to find their total areas. Then, we divide by the area of the square to find that our accuracy is 75%, and that's the math behind it.